Hello everyone and welcome back to Dr. Shoros's classes. So let's solve this question first. So let's quickly remind ourselves of Stefan's study. He investigated whether time of day affects reading comprehension in children, and we had 50 children tested at 9 a.m. and 50 children tested at 3 p.m. And this is the summary statistics, and we already conducted a 2 sample test and we found a very small p-value. So statistically there is a difference. But now we ask a different question. Is the difference meaningful in real life? So researchers don't just care about the statistical significance. Within a large enough sample, even tiny differences can be statistically significant, right? So what we really want to know is how big is the difference. That's where Cohen's d comes in. Okay, now it measures the size of the difference between two means relative to the variability. Now the formula is what? D is equal to mod of bar x1 minus bar x2 by SP. Okay, where SP is pooled standard deviation. Because the sample sizes are equal, we use SP is what? Root over of S1 square plus S2 square by 2. Okay. Now let's compute SP. We have S1 is 4.12, S2 is 4.43. Square both, so 4.12 square will be what? 16.97, and 4.43 square will be what? 19.62, and add them. So 16.97 plus 19.62 is 36.59, and divided by 2, so 36.59 by 2 is 18.295. Okay, now take the square root, so SP becomes root over of 18.295, that is SP is near about, we got 4.28 using the calculator. Okay, so our pooled standard deviation is SP is near about 4.28. Now calculate the differences in means. So this will be mod of 17 minus 0.9 minus 15.2, that is 2.7. Now divide. So D is what? 2.7 by 4.28. D is near about 0.63. Okay. Now let's look at the interpretation guidelines. 0 less than equal to D less than equal to 0.20, not very meaningful. 0.20 less than D less than 0.80, somewhat meaningful, and D greater than equal to 0.80, very meaningful. And our value is D is equal to 0.63, that falls between 0.20 and 0.80. So the difference is somewhat meaningful in real life. Okay, now at the 5% significance level, there is sufficient evidence to conclude that mean reading comprehension scores differ between the children tested in 9 a.m. and 3 p.m. The effect size is D is near about 0.63, indicates that this difference is somewhat meaningful in the practical terms. So children tested in 3 p.m. scored on average about 2.7 points higher than those tested at 9 a.m. and this difference is moderate relative to the variability in scores. Okay, so the statistical significance tells us there is evidence of a difference, and Cohen's d tells us the size of the difference is moderate, and the result can be statistically significant and still not very meaningful, but in this case the difference appears moderately meaningful. Okay, so This was the whole description for this question. Okay, I hope this is clear to you. It's a very interesting question, very nice question. So see you in the next session with a new question of statistics. Till then, bye bye and take care.